Hello everyone. In our last video, we understood how the sensors are made and we understood how resistive and capacitive sensors work. In this video, we are going to talk about sensor programming basics. When we start learning sensor programming, the first thing which we need to understand, and it's a very important thing, that is sensors are input devices. They provide input to our microcontroller. And that clearly means that we are going to use commands, analog read and digital read. These commands will be used to acquire the sensor input. When the sensors are giving us values high, low, or 1 and 0, which means only two values. Such values are called digital values, and hence that time we use digital read command and we call those sensors digital sensors. Whereas we have more than two values, in such cases we call them analog values. And in that case we use analog read command and the sensors are known as analog sensors. For example, a touch sensor is digital sensor. Why? Because it only senses presence or absence of touch. Whereas a light meter is analog sensor. A light meter which is used in cricket matches to check the ambient light, they are analog sensors because they tell you the brightness of the light. When we use analog sensors, we make use of analog pins. And in this case, ADC or analog to digital converter is used to convert this input into a numeric value. And in Arduino Uno, the ADC is 10-bit. And hence the maximum value we can read from this ADC is 2 raised to 10 minus 1, which is equal to 1023. If you remember, when we were using the output devices and when we are giving a value as an output, the range for those output devices was 0 to 255. Because our microcontroller is 8-bit processor. But for the input devices, when we read the values, the range is 0 to 1023. Okay, so now we have sufficient understanding about sensors and we can start talking about the structure of sensor program. For that, let's understand how humans behave. So for example, I'm given a job to get all the Blue House students into one side. Now I know the Blue House students use blue t-shirts, so it is a condition which I know. So that is a condition. Students wearing blue t-shirts, I need to get them to one side. Now how do? I go and I start looking. So I use my sensor. My eyes are my sensors and I start using them. When I see a blue color t-shirt, I send that information to my brain. And brain stores it in one of the memory cells. It then analyzes it. It compares it with my condition. Is that student wearing blue t-shirt? There are two outputs to this comparison, yes or no. If yes, I call that student and I make him or her stand in one side. If the output of comparison is no, then I discard that student. So what I'm doing, I'm taking some action based on the output of that condition. In exactly same way, in our robot, the sensor is continuously looking at the surroundings and acquiring information. What we do, we read that information from the sensor. Then we store it, we compare it with the predetermined condition, and based on the output of the comparison, we make a decision. We take some action. So if I want to structurize what we are doing in our robot, first thing we do is we read value or information which is available at the sensor. Then we store that information somewhere in our microcontroller. Once we store, then we do comparison, we compare it. Compare it with what? A predetermined value. And then finally, we perform action based on the output of our comparison. This is what we do all the time. Whenever we are talking about sensor, this is what we do. We read, we store, we compare, we act. Read, store, compare, act. And we can just remember this. So what we do is we do RSCA. Read, store, compare, act. And that's the general structure of any sensor program. We read the value, we store the value, we compare it with a predetermined condition, and then we act based on the output of the comparison. And we know that in computer, when we want to store, we always need a variable to store it. So if we remember this, that we always need to do is read, store, compare, act, and for storing we need a variable. We will be able to write most of the sensor programs. In our forthcoming videos, we are going to write a simple sensor program where we will revisit our structure of sensor programming.